In our Transitioning to SUSE Linux Enterprise 15 course, we're going to start by looking at an introduction to SUSE Linux Enterprise 15. We'll begin our discussion by looking at the evolution of operating systems, and then we'll introduce you to various components that are different or are changed inside of our SUSE Linux Enterprise product. We'll be looking at the term multimodal, a unified installer, modular plus, package handling differences, the cron D and cron C tools, Firewall D, which is replacing SUSE Firewall 2. We'll look at the 4.12 Linux kernel, OpenSSL 1.1, Wayland, libstorage NG, the SUSE SDK, GCC 7, and some of the versions of scripting languages that have changed. Let's start, though, with an evolution of operating systems. In the past, we have used a different approach for installing operating systems and the way we deploy them in the enterprise. Specifically, we have used a monolithic approach, which means that we have used various tools in order to deploy our operating system, and at the same time we've included a bunch of extra things that you might need or you could be using in your deployments. Now, in our present environment, we use a just enough operating system, which provides an ideal platform for today's agile environments, whether it's a private cloud or a virtualized data center. And our JUICE, that's JEOS, is a perfect minimized host OS for deployment of container applications, for private cloud images, or simplification of IT operations. In your enterprise or data center, you can take advantage of several different flavors of JUICE: KVM, Xen, fully virtualized, Xen paravirtualized, Microsoft Hyper-V, VMware, or even OpenStack cloud implementations. And based on these changes, we can add in those components that we need, whether that be high availability, or if we need to include a more SAP functioning environment. But the future has directed and has given us a need to include even a slimmer baseline to work with, and then add in only the components that you need, leaving the operating system without any extra components selected as thin as possible. This gives us a more modular approach because in order to fully use the operating system, you have to add at least one module into the environment. Otherwise, it's basically just an interface to the CPU itself through the kernel. This brings with it the introduction of the more containerized world, where we have just enough operating system to provide application-specific support. And SUSE's Containers as a Service platform, or CAS platform, is designed to interact with this new version of the operating system extensively. So there are some core themes to keep in mind as we discuss SUSE Linux Enterprise 15. Specifically, it is multimodal, which addresses both a traditional one-to-one hardware relationship, but it also has container capabilities and the ability to work within a software-defined environment. We have a new unified installer, which means that all SUSE Linux Enterprise 15 products are installed by starting a single medium or single ISO. The Modular Plus design is that everything is a module. You have a stable base, but then you add in only the components that are specific to your deployment needs in this or that scenario. And of course, it's designed to be as easy to use as possible, making it so that you install the base environment, but you can search and add all of the packages and patterns across all of the products very easily through a search function. These are all going to be discussed in detail in later sections. Let's talk about multimodal, though, as it's a core idea for SUSE Linux Enterprise 15. Multimodal is defined as meeting two different sets of operating system requirements. There is the traditional infrastructure, which has multiple use cases for a particular operating system. You have both a manual and automatic installation options, automatic through something like AutoYast. You have a variety of different ways to do updates and upgrades and to perform legacy functions on it. There are differences in the way that packaging and installation can be done, and as a result, this is, again, back to what we were saying, almost monolithic, where we can have a very large size, but that also takes a lot more management because there's more packages, more files, more things that we have to maintain. And that's a traditional infrastructure. Now, with the software-defined infrastructure, we have single use cases or multiple systems that are handling a single use case. Our containers and our applications split up. We have an automatic and centralized installation. We keep everything updated because we're centralizing that. And each implementation or deployment is designed to fit one particular purpose and not to fit all of them as in a monolithic install. And the design being, let's make this as small as possible in both size, but that also should affect the amount of management we have to do because it only has one purpose. So that is where operating systems have kind of started to diverge from them. Either we're in the traditional infrastructure or we're in kind of a software-defined infrastructure. So in the traditional infrastructure, we find the SUSE Linux Enterprise and its original deployments and traditional deployments directly to a piece of hardware. And on the software-defined, you might find something like our SUSE Container as a Service Platform product. So these aren't the only things that sit in these two realms. However, they're good examples of the products themselves. If you have a traditional need or server that needs to perform traditional needs and multiple needs, you can install in that manner. But if you need to use and interact with a SUSE Container as a Service Platform, SUSE Linux Enterprise 15 can interact with that environment as well. In other words, we work in both realms or both modes. So how does this work and why does this work? Well, as you look at these two different ideas, traditional installer and use case on the far left of this particular slide, and on the right side we have the more workload-specific containerized version, they all come from the same code base. And a result of coming from that same code base is their ability to interact with each other. They all come from the same place, built from a lot of the same tools, and they bring that capability with them. If we look at a software-defined infrastructure, we find some different ideas here. The basic thing is that an operating system is still required regardless of whether we're doing a fully containerized version of things or if we're deploying a traditional monolithic implementation. Now, we might have, as is shown on the left side here, an infrastructure where we have various release management and making sure that things are running and updated as necessary. And on the right side, we have our public cloud interaction where we can interact with Azure or AWS or GCP if we need to. But all of those things depend on having an operating system that is capable of managing and working within all of that. And that's what SUSE Linux Enterprise does. It works in the public cloud. It works in a private cloud. It can work with a cloud application platform or platform as a service. It can work within container management with CAS platform. We can do various storage functions in a software-defined storage world with SUSE Enterprise Storage. We can do virtual networking using things like software-defined networks and Open vSwitch. So we have a lot of options here available to us, and it all starts with that core operating system itself. So let's try to define a little bit more closely where things sit between Mode 1 and Mode 2. Now, what are Mode 1 and Mode 2? Mode 1 and Mode 2 are the differences between traditional infrastructure deployments, and Mode 2 are those deployments that are in the cloud or software-defined or containerized and so forth. So if we look at this picture here, we could take it and cut it up as is done here, so that we have Mode 1 where we have a traditional data center. We may even have a hosted and managed implementation, and that still fits within Mode 1. We have physical servers and even virtual servers that can sit inside of Mode 1. We have the monolithic application architecture, or we have various tiered services. And we might also have in the development process, we'll have the waterfall traditional methods. We might also have agile development processes in place that still fit within Mode 1. Now, Mode 2, on the other hand, we have cloud deployments, we have containers that we're working with, we have microservices as the applications are changed in the way that they're architected as a whole. And as far as development, we have a more DevOps deployment, which could mean many things to many people. But in this case, we're saying that applications have a shorter time to change. We're very quickly releasing various versions, and there's someone that has to manage that. So Mode 1 and Mode 2, you can see there is some clear changes in the way that we are deploying solutions to our networks and to our environments. And the operating system has to be able to handle all of those things. Okay, there will be a further discussion about this in a later section, but at least you have an overview of what Mode 1 and Mode 2 look like. Let's take a look at the Unified Installer for a minute. The Unified Installer was designed around the idea of a single installer to handle all of the SUSE Linux Enterprise 15 based products from a single medium. So you download it and you can install for SAP, you can install for a straight SUSE Linux Enterprise server environment, you can do the desktop install from there, you can do all of those things right from a single installer. The other idea is that we wanted it to stay small, so there weren't extra things included in the base install that aren't needed, say, if you go between those various partitions that I already mentioned. There's a workflow that goes with this. We start the installer, we select the product that we're going to install. As an example, are we doing high-performance computing or are we doing just SUSE Linux Enterprise Server? We would register the product or select that we're going to evaluate or not really going to register it right now. We can register later. And then we run our product installation, selecting, based on our use case, the modules or extensions in order to get our deployment the way we need it. Now, there are various sources for this install. There are different types, really. There's an online install, which is we use the Unified Installer medium and repositories direct from SCC, the SUSE Customer Center, or indirect via a SUSE manager or via the SMT, which is now renamed to RMT tool. We could do a disconnected install where we're using a preloaded SMT, which isn't connected to SCC. We could do what's called an offline install, where we just downloaded the ISO images for both the installer and all of the packages that are available. Or we could do an image-based install if we're deploying to some containerized or virtualized world. And we can do those as well, all from this installation medium. Okay. We will be talking again more about the installation process in a later section. Well, let's introduce you though to Modular Plus and why that's a little different. We've been using various modules to define our operating systems for a while now. As we have moved from SUSE Linux Enterprise Server 12 to SUSE Linux Enterprise 15, we have modified that approach. We've gotten even smaller in our initial deploy and required you actually during the install process, what are you going to use this server for? So select the components, follow the decision trees that make it look the way that you want it to look, and then you don't have any extra fluff in it. This makes it so that all of our components come out of a single source. Now, let's look at those components. If we look at those ideas a little bit more closely, we can see that SUSE Linux Enterprise 12 has the idea of a single image per each product. In other words, if we're installing SAP on top of SUSE Linux Enterprise Server, we download an ISO that is specific to that installation. And that's how SLES 12 or SUSE Linux Enterprise 12 was designed. Now, we do still put modules on top of it. And if you want to develop, you would purchase and register and use the software development kit in order to help you to manage the deployment and creation of applications to work on top of that. Now, with SUSE Linux Enterprise 15, however, all installations from a single medium, everything is a module, and the SDK is now integrated into the product itself so that you have access to it should you need to. What's the logic behind that? Well, we figure that if you have access to develop apps on our environment or in our environment natively, having registered the product or even to just try it, then you're going to do that. You don't have to pay extra money to build on top of us. We want to make that as easy as possible. Now, let's take a look at kind of how these products are related to each other. You'll notice that at the beginning, you select the base system, you select what types of applications, and there's some sharing between, say, a SUSE Linux Enterprise server deployment and a SUSE Linux Enterprise desktop deployment. But based on the product that you've selected, you get presented with various modules that you can put in. Now, there is some overlap. A lot of the things that you can install on a SUSE Linux Enterprise desktop environment can also be installed on top of SUSE Linux Enterprise Server. But there are some things that you can't. You can't put high availability on top of a desktop implementation, which should make relative sense to most people. So what exactly are the modules that are available to you? Well, this is a good list of what's out there. You have the base system, you have the desktop applications, you have server applications, you have high availability and high performance computing modules. You have your SAP applications, your desktop productivity tools. You have development tools that you might want to include, containers, public cloud integration, and a legacy application component or module that makes it so you can integrate with older technologies that may be legacy but are still needed in order to support existing infrastructure and existing applications. Now, Also note that not all of these are available with all products or in all combinations, and there are some decisions that have to be made. However, logically, they should be consistent with each other. In other words, desktop productivity tools and development tools might go hand in hand, but not necessarily required. So, again, we'll talk about that later on in the next section or in following sections. Let's talk about package handling. We've tried to make it easier for you to find the packages you want to install. It is now easier in that you can search packages across all products, all extensions, and all modules from inside of the software that is included for searching and working with packages inside of a SLE200 machine or a SUSE Linux Enterprise machine. This allows you to avoid those missed but available features that you may want, but you didn't know were out there because you didn't have the appropriate extensions and modules loaded. This makes it so we can also see different policies and entitlement needs that you might need in order to have access to those tools. And it allows customers to mix and match those requirements appropriately. This also makes it so that it's traceable, so we can see which packages are being used, and of course compliance is built into it. So what about core technical changes? Well, one of the changes is the use of cronny instead of NTPD. It is important for many applications, LDAP, high availability clusters, any database cluster, a database environment, a storage cluster, etc., that we have appropriate time sync between all of those nodes that are in communication or that are going to interact with each other. And the legacy NTP daemon, which shipped with SUSE Linux Enterprise 15, has been replaced with the cronny that has two parts. That's cronny D and cronny C. The D is the daemon or daemon that can be started at boot time, and of course the C is the command line interface for monitoring and interacting and extracting information about what's going on with it. And of course, there is a separate section in this course to discuss that. There is also the replacement of the SUSE Firewall 2 utility, which has been a part of SUSE for quite some time, with Firewall D. In the past, we used SUSE Firewall 2, but with Firewall D, we get a couple of new tools. Firewall D is the tool that maintains the IP tables packet filtering, and then there's a Firewall-config tool, which is a graphical tool for performing that configuration. There are also some command line tools that can be used to interact with it, and we'll be discussing those later on as well. Now, there are some more changes that we have brought to the table with SUSE Linux Enterprise 15. We have the use of the 4.12 kernel, Linux kernel, which brings with it a bunch of performance and enhanced features as well. We have the use of OpenSSL 1.1. This also brings with it the deprecation and removal of OpenSUSE 0.98 and the deprecation but still available through the legacy package of OpenSSL 1.0. We'll be talking about that later. libstorage is a replacement for the previous library that was used for storage-related tasks in YAST. The libstorage NG, next generation. The core idea of this change is that it keeps all information about storage devices in what's called a graph instead of a list. Now, a graph simply maintains some relationship definitions between the various items, whereas a list is exactly that, just a list. And we'll go into technical details of this a little bit later. Wayland also shows up. Wayland is a replacement for the Xorg tools on top of the desktop. There are reasons for it. Xorg is a little bit slow. It's established, though. It's been around for a very long time, and there are some inherent security concerns that come with X11 and the way that it does client-server functions. and we'll talk about that. We'll talk about GCC 7 being the default included with the SDK and for the applications that are included in SUSE Linux Enterprise 15. We'll talk about the scripting languages, the various versions of Python, Perl, and PHP, and where they are. We've also made it easier for you to perform upgrades from previous versions. There are additional paths for doing the upgrade. We will talk about that in later sections. That's actually the last section of the course. And so there will be a bunch of different ideas that we will cover as part of this course.